Okay, there's a clinic that says that they can help you stop smoking, and they claim that more than 58% of its clients have stopped smoking. So I like to think by now that when you see more than 58, you'd say, well, the null is equal, so more than would be an alternative type of thing. So that clinic is claiming a greater than type of thing, and so that clinic, again, would be in this case the alternative hypothesis. Okay, so take it back to the notes. More than, that's an alternative type of statement. All right, and so then the null would be equal. So let's assume that it's equal to 58. Now actually on our picture, this is going to end up being the opposite of that, less than or equal. It's going to be, it'll work out. Just put equal, it's fine. Okay, so there's the clinic claimed if you come here, more than 58% of people will stop smoking. And we say, okay, clinic, prove it. We're going to give the benefit of the doubt to this and see if there's evidence to prove otherwise. Innocent until proven otherwise. Test statistic, all right? That's basically our jury there that's going to make this verdict for us. And so we go back. Here we go. So now they want us to use 3% significance. I'll point out the test statistic here is Z. So the visual would there again be the standard normal bell curve, 0 in the middle, and with a 3% level of significance. We're only given 3% of the bell curve to the clinic, and they said greater, so we're going up here on the greater than side and putting 3% in that upper tail. And we're going to give the rest of the bell curve to the defendant, right? So there you go with that slippery concept of reasonable doubt. Now, we need to find the z-score that resides at that place. And as always, this table wants that middle sliver. So the upper half of the bell curve, 0.5 minus upper tail, leaves 47% for a middle sliver. This has all been done many times. I go back and review assignments 16, 17, 18. But if that middle sliver is 47%, the closest I see is 46.99, and that lines up with 1.88. And note this is on the upper side, so that'll be the positive. And again, the hope would be that you would see that if we put numbers in here and get a z-score that's beyond the 1.88, if z turns out to be greater than 1.88, we're going to reject the null hypothesis. So again, this is all in reference to rejection. That's called a rejection region, right? That upper tail there. And this is its description. So that's why there's a double arrow there to show that they relate to each other. So, like I said, the judge is done giving his instructions to the jury. Go collect some data. So, a consumer advocate sampled 82 of the clinic's clients, and of those 82, 51 had stopped smoking. 51 out of 82. Now I think 51 out of 82, if I'm not mistaken, is a nasty decimal. It is. So here's something we're going to have to talk about. I'm going to write down what that's approximately equal to. It's about 62%, which is obviously more than 58. But that's not enough evidence to say that the clinic is right just because one sample led to a number higher than 58. You know, so you don't look at that and go, 62 is higher than 58. That's good enough for me. I'm going to convict. Now, that circumstantial evidence is that 62 that we observed significantly different than the 58. So, now, when putting this in, you don't want to just put 0.62. I would suggest you leave it as 51 over 82 in your calculator and be creative with storing numbers, and there's all kinds of conversations we could have. But for the sake of accuracy, I'm going to put that as 51 over 82 for p hat minus the 0.58. And then, you know, this is PQ, 58. let's see, what's the complement of 58%? 42%, right. 1 minus, and then over 82 would be our sample size. So, you know, here you get your PQN, N sample size, PQ would be these assumed percentages. Remember, that's why it's called a hypothesis. We're assuming it's true for the whole population. So, you know the drill. You can cheat, you can look at the next slide, you can see what it crunches out to be, hit pause, hit buttons. I don't know what to tell you. It would be more fun if we could do the number crunching together, but it turns out to be something like 0.77. And, you know, I think it's fair, all right? Crunching numbers like that, that's the order of operations. That's an assumed skill you brought with you. But the 0.77 on our picture is, I don't know, fancy way of saying it is it falls shy of the statistical threshold. It's not beyond the 1.88. It is not enough evidence to reject that null hypothesis. So there again, who won the court case? The null hypothesis. Did we get a z-score beyond 1.88? We did not. So we're not going to reject the null. The null won. Okay? So the null hypothesis won the court case, so to speak. And so we will not reject that null hypothesis. And, okay, now it's really important. How is the question worded? It says, is the clinic's claim valid? Well, the clinic said this. Did that claim win? No, it did not. So, at the 3% level of significance, we should say that the clinic's claim is not valid. So, I will say it again, that interpretation, that conclusion, was formulated by using the wording of the very original question. So, you have that in print in front of you from the PDF that was sent to you. So I think it's okay for me to stop right now with this. And so there you go. Now, let's see. We haven't clicked many links here, and I've discovered that for some reason my videos are behaving strangely. But, I don't know, speaking of the null hypothesis and the hoe, let me see if this one works.
Less than a minute now. 25 for 200. This term for a long-handled gardening tool can also mean an immoral pleasure seeker. Ken, what's a hoe? No. Whoa! They teach you that in school in Utah, huh? Al, what's a rake? A rake is right. You select, Al. 400, please.
All right, so anyway, Ken Jennings, actually, greatest Jeopardy player of all time, but anyway, we'll just leave it at that. I think there's 2 more of these we'll enjoy.